In the last video, we talked about trig equations, like sine of x. Let's use cosine this time. Nothing like starting a video with making a mistake. Cosine of x we'll say is root 2 over 2. And I will say that 0 is less than or equal to x is less than 2 pi. So we can make these things solvable with finitely many solutions if we do some kind of range restriction. If we're looking at angles who give cosine values of root 2 over 2, on the unit circle we're probably looking at pi over 4 in the first quadrant and 7 pi over 4 in the fourth quadrant, and that's it. The list is finished. This problem is done. The last video I promised these were going to get more complex, and they are. The complexity is going to come from us adding things into these problems. If the only thing in here is an x, this problem is easy mode. You just find all of the angles that give you this cosine value on the unit circle and you're done. When there's weird stuff happening to the x on the inside of this cosine, this has become an ordeal, and now we have to figure out how to do it. We're still going to look at the same range. I'm only going to look at things between 0 and 2 pi. But that there are things happening to x before I hit the cosine of it, it's going to make approaching this problem a little less intuitive. And the way that I think that you should approach these problems is the same way we approached, or let me not reference the other video. Let me just start this thing over. You should start with the angles that give you root 2 over 2. There should be 2 of them on the unit circle. We already found them. It's pi over 4 and 7 pi over 4. These are the things that 2x equals. But then you should list a couple more. We know about coterminal angles. We know that these things keep spinning. Pretend like this range restriction doesn't exist and list a handful of options here. 9 pi over 4. If we keep adding 2 pi, the next one should be 17 pi over 4. Here we'll probably get 15 pi over 4, 23 pi over 4, dot, 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 dot. These lists keep going. So these are all angles. If 2x, the thing that goes inside the cosine, if 2x comes out to be these angles, we will get cosine values of root 2 over 2. These two came from the unit circle. These came from coterminal angles. So as you keep going in this direction, you're adding things that are coterminal. And for certain problems, we might want to subtract things that are coterminal as well. For this particular problem, I'm not going to worry about it, because if I subtract anything, I'll get negative values. And I know that the negative values aren't allowed. So I have a list now of 6 things, and I could add more to the list if I want, but 6 is probably a good start. I have a list of 6 angles that if these angles were equal to 2x, I would get root 2 over 2 as the cosine value of that 2x. And from here, if I want to solve for x, I have to treat this like it was an equation and divide both sides by 2. 2x divided by 2 will give me x. This thing divided by 2 would give me pi over 8. 9 pi over 8. 17 pi over 8. And again, I could continue this list if I wanted. This thing divided by 2 will give me x equals 7 pi over 8. 15 pi over 8. What is that? 23 pi over 8. And I could keep this list going if I wanted to also. So this is the basic strategy here. When you have a cosine of something equals a number, start with this number. If it's a cosine value, that means you're looking for x values on the y-axis, or x values on the unit circle. Blah, x values on the y-axis. That doesn't even mean anything. You're looking for x values on the unit circle, and there should be two angles that give you that. Expand those lists using coterminal angles by adding 2 pi, so you have a nice list. Once you have those lists for whatever was inside the parentheses, in our case 2x, you have to start doing algebra on the 2x. In our case, we had to get rid of the 2, so we divided by 2. If there had been something being added here, like 2x, I don't know, plus pi, first we would have had to subtract out the pi, and then divide by 2. So it's all about solving the equation from here. We divided by 2 to get x by itself. When you divide all of these things by 2, you get pi over 8 instead of pi over 4, 9 pi over 8 instead of 9 pi over 4, etc. So now we have another big list of all the things x could be. And now is the last step. We have to look at which of those values we're allowed to use. Pi over 8 is in this range. That one's good. 7 pi over 8, that's in the range. That's good. 9 pi over 8 is in the range. That's just a tiny bit over pi. 15 pi over 8 is also in the range. That one's safe. 2 pi is sort of the cutoff here. 2 pi is the threshold. And in terms of eighths, 2 pi is the same as 16/8 pi. So 15/8 is less than that, and that's safe. 17/8 is too big. This one's no good. 23 pi over 8 is too big. That's bigger than 2 pi. So these are the 4 solutions you get. I said that this process, once you start doing things here, would be something of an ordeal. It was going to get more complex. The complexity is these solutions, 9 pi over 8 and 15 pi over 8, are in the correct range, even though the angles that they came from are not. And that's sort of the tricky part. You don't care where the original angles came from. You only care whether or not the final x values are in this range. Which is why we need to list a lot of stuff that isn't originally in the range so that we can edit it with this algebra and get stuff that may or may not be in the range. That's the technique here. I'm going to do another one really quick. Okay. Let's do another one. Let's do sine values this time. Let's say the sine of 3x plus pi equals I'll say 1/2. The sine of 3x plus, actually, let's do something else. This will be an excellent opportunity for me to just add a step that the homework will sometimes do. Let me say 2 sine of 3x plus pi equals 1. And again, I'm going to say that x is definitely in this range from 0 to 2 pi. So for this one, the first thing that we have to do is we have to isolate the sine by getting rid of this 2. So we'll move straight to the sine of 3x plus pi equals 1/2. 1/2 is a y value that appears pretty frequently on the unit circle. So we can look at which angles create a sine value of 1/2. So 3x plus pi, these are our angles. This is the stuff that goes into the sine function. This stuff, if we want the sine of it to be 1/2, is going to have to either be pi over 6 or 5 pi over 6. These are the 2 angles on the unit circle that produce this as their sine value. Based on these 2 starting points, I'm going to add more things to this list that are coterminal. Just by adding 2 pi to these things. And 2 pi is the same as 12 pi over 6, so we'll do a 13 pi over 6 here, and a 25 pi over 6, and a, let's say 37. That's probably big enough. But I'll still add some dot dot dots because I could expand this more if it's not big enough. Here I'm going to add 12 pi over 6, so that will give me 17 pi over 6, and 29 pi over 6, and 41 pi over 6. Let's hope that's big enough. We'll do another dot dot dot. So, these are all of the values that 3x plus pi could equal. So the next step is I need to subtract pi from both sides of this equation. Subtracting pi from the right side of this equation will just leave me with 3x, which is one step closer to being solved for x. Subtract pi. Subtracting pi from all of these things, actually, let me add just a couple more, just in case. I've got the horizontal space. 49 pi over 6, and 53 pi over 6. Okay, subtracting pi from all of these things is going to mean a lot of common denominators, and I need to subtract it from every single one of these guys. So, pi is the same as 6 pi over 6. So when I subtract pi from this, I should get negative 5 pi over 6, 7 pi over 6, 19 pi over 6, 31 pi over 6, 43 pi over 6. Subtracting pi from the bottom row should give me negative pi over 6, 11 pi over 6, 23 pi over 6, 35 pi over 6, and 47 pi over 6. So, this is just subtracting pi, which is subtracting 6 pi over 6. The arithmetic here is not difficult. It's 13 minus 6, 25 minus 6, 37 minus 6. It's just that there's a lot of it. So bear with me, hang in there. From here, all I have left to do is get rid of the 3, and I'm sort of out of room to do that, so I need to start erasing something else. I guess I have to erase this thing in the middle so that the original problem stays. I wish I had a bigger whiteboard. That's alright. So from here, the next step is to divide, again, both sides by 3. If you divide 3x by 3, you just get x, which is nice. If you divide these infinitely long lists by 3, you get new infinitely long lists with different numbers in them. So negative 5 pi dividing this by 3 is the same as multiplying the denominators by 3. It's the same as times 1/3. So this will be negative 5 pi over 18, negative pi over 18, 7 pi over 18, 11 pi over 18, 19 pi over 18, 23 pi over 18, 31 pi over 18, 35 pi over 18, 43 pi over 18, and 47 pi over 18 as a start. Again, if we need bigger numbers, we can add bigger numbers. The pattern here is still pretty clear. Pattern is just plus 12 on the top. The bottoms are all 18s, the pi's are all still there. If we need an additional number, it would probably be 55 pi over 18, because you're just adding 12. So this is my list for possible x values. I'm finished editing this x. It's by itself. Now I just need to compare this list to my range. So this one is negative, that's less than 0, this one's out. This is negative, that one's out. This is, that one's good. It's between 0 and 2 pi. This is between 0 and 2 pi. This is a little bit more than 1 pi, so it's good. This is still less than 2 pi. If the denominator is 18, 2 pi should be 36 pi over 18. So I'm looking for numerators that are less than 36. So 31 is still good, 35 is still good, 43 is too much, 47 is too much. This problem has 6 solutions, and there they are. So again, the basic plan here is you're going to look at angles that give you a sine value of 1/2. I've already erased it, but there should be 2 sort of principal angles that you can find from the unit circle to use to start your lists. Based on those 2 angles, on rare occasions there will only be 1 if you're at the very edge of the unit circle. Like if you're looking for a sine value that equals 1, there's only 1 angle on the unit circle that gives you a sine value of 1. Same with -1. Only on those extreme edges, extreme top and bottom, extreme left and right, will you see exactly 1 answer here. But usually you're going to start with 2 angles on the unit circle that give you this sine or cosine value. So write down those 2 angles. Use those 2 angles and coterminal angles to create a list of possibilities. Do algebra on your list by dividing by coefficients. Usually you divide by coefficients second. First you may have to add or subtract constants that are being added. So do this algebra by adding or subtracting those constants, and then do more algebra by dividing by your coefficients. You get a big list of edited angles. Compare your big list of edited angles to your range restriction and figure out which ones are correct and which ones are extraneous. And then type all of the correct answers into my math lab. That's the general plan. And that's it for me in this video. I hope that that was relatively clear. If it's not, let me know. You have my contact info. You can comment on this video if you like. I'll probably read that eventually. Good luck.